Fractional distillation is a method of separating hydrocarbons that you find in crude oil into more useful groups called fractions. Fractions all have a similar boiling point, and therefore we have similar properties, and we can use them for specific purposes. So, for example, if we have the petroleum fraction, it's a mixture of chemicals with similar boiling points. The boiling point range in petroleum is around 25 to 150 degrees C, depending on exactly which refinery we're talking about. But it contains different chemicals such as pentane, hexane, octane, and you can see the boiling points there. But all of them end up in a mixture. And so what we're trying to do to make this mixture of similar chemicals is we're trying to fractionally distill them. So here is a diagram of a fractional distillation chamber, and in reality these could be tens of meters high. You can look at pictures of oil refineries. These are the things which stick up into the air. There is a furnace at one end, and that's really important. The first thing that happens in the furnace is that we heat up the crude oil. Now you can see, if you look at all these molecules go through the fractional tower, you can see that these separate out into their different fractions, and the different fractions are collected at different heights in the tower. And we're going to just break that down a little bit and try and explain why that is. So let's start with a little bit of a caveat. All of my chemicals here are coloured just to make it easier to see. Crude oil is not really rainbow coloured. Most of what you see here is colourless, so that's difficult to show on an animation, so I've used colour. But if we take a step back, let's have a look at it step by step. First of all, the furnace is there to vaporize everything, to make sure that it's as hot as possible, and that could be something 400 to 600 degrees C. Okay, we're going to heat it up really, really hot. The furnace is going to heat the crude oil up. That's going to be all injected all at the same time into the bottom of the column, and because you've got hot crude oil going into the bottom of a metal column, that metal column is going to become really, really hot at the bottom. And it's going to stay hot because we're going to constantly pump vaporized crude oil through. This isn't a one barrel at a time sort of thing. This is constantly passing through. I've just simplified it for the sake of today's animation. So the first type of chemical that we can collect is something called residue, and I said it was a vapor. I said it was vaporized, and that means it's a mixture of gas and liquid droplets. And basically the liquid droplets are not evaporated substances, and because they haven't evaporated, they are still liquid. They will come into contact with the surface of the column, and they will drip down to the bottom, and they will these are the red ones here, come out of the bottom as residue. Everything else is going to go up the column, and as it goes up the column, it's hot at the bottom, but actually it's cold at the top. It's air temperature at the top, so that might be something like 25 degrees, 20 degrees at the top. And so if we have a look at the grey particles here, they're going to cool as they rise, and when they get to their boiling point, they will cease to be a gas, and they will turn back into a liquid, and they will condense. So the grey particles are going to go through here, they're going to rise to this first step, and they're going to condense into a liquid and be collected. So why do they go up and the red ones went down? That's to do with their boiling point. The red ones will have the highest boiling point. They wouldn't turn into a gas at all. Grey ones here, out of our mixture, we have a slightly lower boiling point. So they will evaporate into a gas into the furnace, but as soon as they go even a little bit up the column, they're going to turn into a liquid because it's going to get cold enough to do that quickly. So they might have a boiling point of something like along the lines of 350 degrees or something like that. So the next particles coming out of the dark orange ones, they're going to go further up the column again. These ones have a lower boiling point than the grey ones, and therefore it needs to get colder to turn them back from a gas into a liquid, and so we have to go further up the column. So the yellow particles have an even lower boiling point here, They're going to go up the column even further before they get cold enough to turn back from a gas into a liquid. And then we have the blue particles, which again, they're going to have an even lower boiling point, and so therefore they're going to go even further up before they get cold enough. Each of these chemicals is turning into a gas in the furnace, and then it's all about how cold they need to be to turn back into a liquid. And the colder they need that to be, the lower their boiling point, the further up they go, until we get to the top bit here. We have the green particles are going to be the last ones to come out there. Now those are all collected as liquids. The white particles I've got here are going to come out at the top, because they don't condense at all. Their boiling point is so low that even at room temperature they are still gases. So they're actually going to stay as a gas all the way up, and instead of condensing and being dripped out, they're going to come out of that tube at the top. They're going to be collected as something called refinery gas, and this is what's made into things like LPG for barbecue heaters, and some cars run on it now, but that's what's called refinery gas. But I've shown you it step by step. What you've got to understand is that this is all happening all at the same time. So all of the chemicals go in simultaneously, and there's no end to this. There's just a beginning. You pump crude oil in, and all of these particles are constantly being added in and separated out by this idea of boiling point. So as they go in, they get heated up. As they go into the column, they either drip out as the residue like that, or they will go in and rise up the column until they reach their boiling point, and then they'll be separated out when they come to their boiling point. And that's the process of fractional distillation.